These minerals tend to solidify under heat and form a scale on any vessel containing water, be it in the tea kettle or in the steam boiler of a modern factory. This scale decreases the efficiency of the boiler and must be removed or prevented. When used for laundering or other washing purposes, hard water develops a scum known as hard water curds. Makes washing more difficult, requires more soap. Though hardness of water varies in different regions of our country, a large portion of the United States has hard water, as you can see. The darker areas indicating harder water. Again, we are indebted to salt for helping us change hard water to soft. In the home, in the factory, salt is the key to our soft water supply. Salt pellets in this appliance help turn hard water to soft, making washing easier, faster, more economical. Soft water is also vital to many industries, and salt makes it possible to provide the tremendous quantities needed at the lowest possible costs. How fortunate we would be if salt were everywhere close at hand on the surface of the earth. But it isn't. So man must search, find it elsewhere. In some cases, deep in the earth. Here, 700 feet underground, you are literally surrounded by salt. The pillars, the ceiling, the floor, all solid salt. From thick beds like this, from great salt domes, you can mine it as you would mine coal. But it is always clean and comfortable down here, and the temperature all year round is like that of a clear October day. Giant pillars support the roof of the mined-out area. These, for example, are approximately 80 by 100 feet. The mining operation begins, and the face of the salt wall is drilled for dynamite charges. The undercutting machine now moves in, cuts a gap across the bottom of the section that is to be mined. Blasting powder is now tamped into the drilled holes and prepared for firing. Some run-of-the-mine salt is sent directly to industrial users with no refinement. For other uses, it must go through further processing steps, some simple, some complex, before it is ready to be shipped to serve America in a multitude of ways. For instance, in winter, snow is great for sledding and skiing, but if workers, trucks, and shoppers are snowbound, the economic loss can run into millions of dollars per minute, not to mention the toll in human suffering if doctors, ambulances, police, and fire equipment were to be immobilized. Salt, with its fast melting characteristics, is the most effective and economical material to clear thoroughfares. As shown in this simplified demonstration, its action penetrates and quickly perforates ice and snow and loosens the bond at the surface of the pavement, leaves roads open safe. In fact, all year round, salt plays a prominent part in serving the rolling wheels of commerce, industry, and agriculture. For instance, in the building of roadways, it serves in a number of soil stabilization uses. Let's see just how. The soil in each of these containers is exactly the same, with one exception. Salt has been added to this one. Salt binds the soil, furnishes an excellent subbase for concrete and asphalt highways and city streets, produces better, harder, longer-lasting rural roads at less cost per taxpayer dollar. Now you begin to understand why methods and machines are constantly being improved and extended to keep pace with the constantly increasing demand for more and more of this vital commodity. The third method developed for salt recovery is drilling. By a stretch of the imagination, you might describe this hydraulic process as mining by pipeline. More than half of our total salt supply is produced by this method. Fresh water is pumped through pipes into the well, and the resulting saturated brine is then forced up, creating a high-quality product that finds its way to your tables and into many other uses. The brine, pumped up from the well, goes into these large settling tanks. Chemicals remove impurities. The purified brine moves on into airtight evaporators called vacuum pans. Salt crystals form, sink to the bottom of the cone. A rotary dryer takes the wet salt and reduces the moisture to less than 1%. Last moisture is removed in this great kiln, where the salt is tumbled and baked. After cooling, dry salt emerges, moves on its way to be screened and graded. Different sizes for different uses. As it goes through a series of screenings so that the crystals of different sizes can go into their proper bins, let's follow the salt you're most familiar with, the perfect crystalline cubes of pure table salt. Here are the uniform crystals for table salt. Each salt cube is given a coating to make certain it will be free-flowing, so that when it rains, it pours. A seemingly simple operation, this, but how important it is to produce iodized salt. A minute amount of an iodide ingredient is added to prevent simple goiter. To protect the free-running qualities, to assist in preventing the loss of iodine, each can is made up of several plies of paper with an asphalt impregnation between. In addition, the label has been lacquered so that it too will form a moisture barrier. Here in this modern research laboratory, the first in history devoted to that simple substance salt, skilled technicians are looking to the future, constantly seeking new uses of salt to benefit mankind. Salt, from tiny soft water pellets to 100-pound bags, made in 100 different kinds and grades. Serving agriculture, serving the rolling wheels of transportation, the food industry, salt for canning, salt for the fisheries, salt for the meat packers, salt for home meat curing, and for many household uses. Salt, the pure white crystals of sodium chloride, serving the wonderful world of chemistry. Without this essential mineral, such vital and useful products as these would not be possible. Synthetic rubber, plastics, textile bleaches and dye stuffs, pharmaceuticals, cosmetics, paints and varnishes, insecticides, fire extinguishing fluids, glass, salt, strategic material, vital to our national defense. A compound of sodium and lead, for example, becomes part of the tetraethyl lead so important to high-octane aviation gasoline. Sodium from salt helps obtain lighter, stronger metals. Gears of military machinery undergo terrific strain. These gears are case-hardened in a bath solution of sodium cyanide to give them the necessary toughness. Salt in explosives. Salt essential in munitions. In the peaceful use of atomic energy for power. For our future defense in the coming space age. Salt, serving America. And her need for it has more than doubled since World War II, due largely to the tremendous growth of our chemical industry. But salt has kept pace with our changing needs, and it always will. If you want a dash of salt for your food, if you want carloads, as an individual, or as a community, or as one of the 60 major industries depending on this vital mineral, no matter where you are, rest assured that you can have exactly what you want, when and where you need it. Salt from the solar ponds. Salt from the wells. Salt from the mines. No matter where you live, where you work, there will be salt, often unseen, unrecognized, but there to serve you and yours with the indispensable crystals of life.